Good evening, everyone. So we are here live for our November Mobile CSP webinar. This one is going to be on the Unit 6 on some of the data lessons that we weren't able to cover very completely in the summer professional development and lessons that we've updated last year. So you're a returning teacher or somebody that just went through ED for the first time this year, hopefully you're going to find the information that Shannon and I are going to share useful for you this evening. So I'm Jennifer Rosato, and I am one of the project directors. I primarily work with the online professional development, and I'm also a professor in the computer science department at the College of St. Scholastica. So I come from that background. This evening, I have with me Shannon Sakar, who is from West Hill High School in Stamford, Connecticut. He is one of our mentors or master teachers for a hybrid group, and that was the group that was based out of New York City this summer. He helped update some of the lessons in Unit 6, the ones especially that were converted from using TinyWebDB to using the Firebase database. Share with us his impressions and expertise on that part of the App Inventor lessons in Unit 6. So I'm just going to start sharing my screen here and go through a couple slides that give an overview of Unit 6 and the data project, or data units. I'll just remind you that if you're watching the live stream, you have an area where you can leave comments and questions. Like I said, I will give an overview of the project. Shannon will present information about the App Inventor lessons, and then we'll take a moment to pause for questions and answers from you. And then I'll go over Fusion tables and the data project, and we'll have some time to answer questions at the very end. So if you have any comments or suggestions or questions, please feel free to post them in that comments area on the YouTube watch page, and we will get to them when we pause after the App Inventor lessons, and again when I pause after the Fusion tables section. So let me start my screen share. Great. So like I said, we'll just go through a little bit of introduction. So myself and Shannon, like we just did, and then an overview of the unit, the App Inventor lessons, some of the Fusion table lessons, saving plenty of time for Q&A at the end, and any resources, and just a reminder of future webinars. So these are the key learning objectives related to big idea number 3 in the Computer Science Principles Framework. One of the 7 big ideas is titled Data and Information. That Computer Science Principles has been set up, and our Mobile CSP curriculum has been designed to meet. There are several key learning objectives that we're aiming to meet as a part of this data unit. So the first one is about finding patterns and testing hypotheses with this data and information. Another one is that we want students to collaborate when processing this information and data, because usually by collaborating, they can discover and learn more about the data than just thinking about it on their own. We also want them to have some practice with designing and exploring visualizations of information. So not just to take that data, but to process it in some manner and create a visualization that can be helpful for others to understand that data. We want them to be able to extract information from the data and explain connections or trends. So after they create their visualizations, they should be able to explain what they've learned from that process and identify any trends that they see in it. We want them to determine how large data sets impact the use of computational processes to discover information and knowledge. So to have a little bit of experience with exploring large data sets and how those differ from some small data sets they may have used with Excel or other tools in the past. And we also want them to analyze how data representation, storage, security, and transmission of data might impact or involve the manipulation of that information. So those are the learning objectives that are aimed at that big idea number 3 in the Computer Science Principles Framework. All of those are identified in the lesson plans on the Teach side and the unit overview framework. So the unit is kind of divided into 2 different types of lessons. There's a series of App Inventor lessons that explore how data is used in App Inventor. And then there's a series of lessons that explore how data is used in other ways. So the App Inventor lessons include the President's Quiz tutorial, the President's Quiz projects, abstracting data to the web, which is also based on the President's Quiz app, lists of lists, and abstracting data to the web project. That last one is optional, but again, all of them are based on this initial President's Quiz app, which is a pretty straightforward kind of quiz where students are asked to create a quiz that has an image, a question, initially a text box where they input their answer to the question. They click the check answer button, and then they click the next button to keep cycling through questions. So some of the key ideas that they're going to be learning out of these App Inventor lessons include the idea of parallel lists. So in the President's Quiz app, there's a list not just for the questions, but also a list for the images and for the answers that go along with it. And they are learning how to use an index variable to keep track of where they are in all three of those lists. In abstracting data to the web, we introduce students to the idea of Firebase, or a web-based database. So the capability of storing information in the cloud between uses of the app and being able to use that from multiple apps, that kind of idea. In lists of lists, we convert that text box where students put answers into the quiz into a list picker so that it's more of a multiple choice kind of quiz. And in order to do that, we use nested lists, or a list that is actually made up of multiple lists. And then finally, there's some optional abstracting data to the web projects where they use Firebase and the concept of nested lists together. So those are the App Inventor lessons in the unit, and they pretty much go in terms of like in order. You can go through them in the unit. And then the other lessons that are non-App Inventor ones include this first one on big data, which is an overview of some of the general concepts related to big data, where data is collected, how different people and organizations leverage or want to use data, some initial thoughts or concerns about data security and privacy, that kind of thing. The next two lessons go together kind of as a pair. So lesson 7 is visualizing data with Fusion Tables. Fusion Tables is an app that you can use as part of Google Drive, and I'll walk you through a quick demo of it later. And it really allows students to import data sets and create a number of different visualizations, including various charts and graphs, as well as the ability to create maps when the data includes geolocation information like latitude and longitude. After that, there's a data visualization project where students work in pairs to analyze a data set of interest to them. So very similar to what they did in lesson 7, except they're exploring it more on their own and of a data set that they are interested in particular. And finally, the Blown to Bits lesson for the unit is on data ownership. Who owns the bits? Where is responsibility for using those bits? Where does that lay? And what kind of responsibility do you have as a person who might be using data or other types of files and stuff that might be found out on the internet? What kind of responsibilities do you have to cite that information and when you share that information with other people? So that's just a quick overview of the two different types of lessons. I'm going to turn it over to Chandon now to go through the App Inventor component, data components. And so he's going to give you a quick overview and then demo some of these in App Inventor for you. Shannon?
Okay, Jen, can you hear me okay?
Yep.
Okay, terrific. So I'm going to talk for about 10 to 15 minutes on the Firebase portion, and also just talk a little bit about list of lists, which is a much smaller topic. So one of the big differences that we're going to have in Unit 6 this year versus last year is that we used to previously use a product called TinyWebDB, and this year, for the first time, we've switched over to this Firebase product, which is now a Google product. Google bought Firebase a while back. But let me just take a step back and talk a little bit about the two different kinds of databases that the students are going to be using throughout the year. Now, I think you've either already done or soon will be doing the lesson using the TinyDB. And there, of course, it's very much like reading a variable where you simply read it and move on with your work. And there's not much difference between using this database and using a bunch of variables inside App Inventor 2. But the new concept that we want to explain to the students on Firebase when we get to that lesson is that Firebase, unlike TinyDB, which is synchronous, Firebase is an asynchronous database. And the analogy that we want to use there is that, let me just switch over to my screen here. Okay, Jen, can you see that picture?
Yep.
Okay, terrific. So the analogy we want to use here is we want to describe the difference between a phone call and a text message. And here, of course, we have a synchronous event. This is similar to the use of the TinyDB, where basically we're reading information from the database and we're sitting right there waiting for it to come back before doing anything else. Whereas Firebase is an asynchronous database. And so there, what we do is we sort of send off with a messenger a request to the cloud for information, and then sometime later, and some unpredicted time later, the response comes back, and then we have to be prepared to handle it at some time. And that's the big change in the mindset between the TinyDB and the and the Firebase database that's we're going to be using in Unit 6. Now, I just want to take one moment to show you what came before Firebase. This is what we used to have in previous years, which was the TinyWebDB, and just talk for a minute about why we switched over. So this is the old version, and this is the Firebase database that we're switching to. So you can see that it's much nicer, much more elegant. But the other thing, there were several problems with the TinyWebDB. The first is just setting this up, one for each school, was painful. And second, because this is a completely anonymous database, students, once they figured it out, often would put foul language in here, and then you would have the additional job of going in here periodically and cleaning up the database. All these problems are gone now with Firebase. Firebase, the basic version, is free. They use a freemium model, and for our purposes in this course, the free version provides more than an adequate resources for what we need. It's nice and elegant. It's much easier to use. And generally, it's just a much better product. So it's been kind of a win-win. And this is, for example, what it looks like after the database has all been created and set up. You can see that there's a list here for the questions, a list here for the answers, and a list here for the pictures that go along with each of the questions. So these are the parallel lists that Jen referred to in her opening comments. And if you're wondering how to set this up, I'll just show you very, very quickly. If you just go over to Google and just type in Firebase, and then just click on the first link here, it'll take you to this page here. And then you just click on this place right here where it says Getting Started for Free. And it's like a 2-minute, you don't even need instructions, but they are provided in the lesson. You just go there and set that up. And then every student will have his or her own copy of Firebase installed. And then once you install it, you'll be presented with this console. I happen to have 3 databases in here already. You'll start with a blank screen, of course, and then once you're all finished, you'll build something like this. And then there's this tab on the left, which basically shows you the different places you can go in the database. And to see the data, you just click on this database link right here. And then in a second or so, you'll see that the data will show up right here. Okay, so that's basically how we use the Firebase, set it up. And let's see here. How do I go back to the slides here? Here we go. Okay, so I mentioned that setting it up is easier. The security is much better because each student gets their own. The integration with App Inventor 2 is quite good. And I mentioned also that it's free. One last thing I want to mention, you'll notice here that the pictures are not actually stored in the Firebase database. They're stored in this TinyPic server, and I just want to take a moment and talk about why they're not stored in the same database. So even though the most recent release of Firebase does allow images to be stored directly, the interface that exists today between Firebase and App Inventor 2 does not allow for the transfer of images to be handled very easily. So what we've decided to do is use a separate database to store the pictures. Now you might be wondering at this point, why didn't we use Google as our image server? And we found out the hard way that Google tends to scramble their URLs every few days. And we don't know if they do it purposely in order to keep people from using their drives as image servers, or if there's some other reason, but we decided to use the TinyPic instead. Now, TinyPick is free. Let me just show you a picture of TinyPick right here. This is my TinyPick database. You can go there and ask your students to set up an account before you get started with the lesson. These are a bunch of pictures that I have saved. Some of these you can probably recognize from the President's Quiz. And TinyPick works great. The one problem we do have with it, though, because it's a free service, there are some limitations. And one big limitation is that if you don't touch any of these pictures for a 30-day period, TinyPick will remove the picture and reclaim the space. So it's good for working for our demonstration purposes for our course, but if you actually wanted to build an app and keep the pictures permanently, you would have to pay for an image server service like Amazon Cloud or something like that. So just be aware that what the work that you're doing here in TinyPick is, for all intents and purposes, temporary. Okay, but for teaching this course, it's a fine option. If you decide to use something other than TinyPick as your image server, that's fine. I think you'll find there's not a lot of work you need to change in order to get that to work. But for those, most of you, I'm guessing, will want to stay with the TinyPick because the lessons are already built around that database. Okay. Let's see here. There's just looking for the slides. Okay. So that basically, in a nutshell, is how Firebase is going to be used. If I switch over to here's our textbook right here, and the lessons start with Firebase on 6.5, abstracting data to the web. And so as a review, let me just show you what's happening here. So previously, the questions and the images and the answers were all buried inside the app. So what we're doing here is we're using Firebase now to store all the information so that a teacher who wants to update information about the quiz does not need to go into the app, but simply can go in here and just change the data. So the quiz becomes a completely data-driven model. And that's what we're trying to teach the students in this application. Okay, and last thing I want to mention, hit on, is the list of lists topic. So if you go over here on back to the textbook, you'll see that 6.6 has this structure that is a list of lists. Now, I mentioned to you that in the initial Firebase application, we're using parallel lists. So you can see here, there's a list of pictures, there's a list of questions, and a list of answers. And the idea would be that a single index can be used to point and create a single question. So, for example, if the index equal 2, that we would display this picture, we would display this question, and we would be waiting for Nixon as the right answer. Another way to do this, we can switch these answers to be, instead of fill-ins, to be multiple choice. And if we do that, we're going to switch to a list of lists structure. Let me just show you what that looks like. So here, for example, is an example of a list of list structure where we have the outer list, which contains 2 elements, and the inner lists each contain 5 elements. So the first one contains these 5 presidential names as choices, and then the second one contains these 5. So the idea here is the student would first index to find one of these lists, and then find the index inside the second list to get at the particular element. Okay. In most other language, this would be known as a 2-dimensional array. But here we use the name lists and lists of lists to define a 2-dimensional array for this project. I just want to highlight also a lesson that's been added here by Ralph Morelli, which is this 6.9. And this is sort of an advanced version. You'll have to decide for yourself. In my classroom, I'm going to probably only end up giving it to the students that are the most advanced. But this basically allows for the storage of multiple quizzes in a single database. And that's really nice because a teacher can then take all the quizzes, for example, for any topic, App Inventor or anything else for that matter, and store them in a single database. And then using this list of lists structure, we can pick which quiz to present to the student. Okay, so that's basically, in a nutshell, an overview of both Firebase and also the list of lists structure. Now, I know some of you are probably a little anxious about using Firebase. You've probably never used it before. And I just want to suggest to you that you do this exercise twice. So before you come into class and present Firebase, my suggestion is to do this entire lesson on your personal Google account. And then I think it'll relieve a lot of your anxiety and you'll feel confident about it. And then the second time through, when you're in the classroom, use your school account to show the students in real time how to set up the Firebase and do the lesson. So that's basically it for me. I'm going to hand things back off here. I'm going to stop sharing. Okay, Jen, it's back to you now.
Okay. We did have a couple questions come through related to Firebase and using that technology with App Inventor. So let me go back to our chat here. One of the questions was, if you're going to use Firebase, does it install any code on the PC, or is it entirely cloud-based?
As best as I can tell, Jen, it's completely a web-based platform. I don't know if it leaves any cookies behind. I suspect not, but I'm not completely sure. But if there's anything on the PC, it's going to be next to nothing.
Okay, great. So it sounds like if it's entirely cloud-based, or if it just is using cookies, like to keep track of your username to come back and that sort of thing, it would work fine for students on Chromebooks as well as PCs.
As far as I can tell, that should work. I haven't tried it myself, but I think it should.
Okay. Well, if anybody out there does try it on Chromebooks and runs into problems, please let us know. We want to be aware of those, but I think it does look like it's cloud-based and shouldn't be an issue. One of the other questions was related to TinyPic, and one comment was made that if students use TinyPic to build their Create Number 2 project, especially in a fall semester class, it sounds like that might affect their submissions to College Board. But
yes, I don't think that would be a very good idea because of the 30-day issue, and then you'd have to worry about keep touching the pictures to make sure they stand around and stuff like that.
Mm-hmm. Although the submission to College Board doesn't actually include the executable file, it's just the video and then
that's
graphics.
True. Yeah, so once you get it working, you can just tape it and send it. That should be okay.
Yeah. Yep.
Is there some other issue with using TinyPic for the submission that was noted in the question?
No, that looks like it was the only thought, is that maybe when it goes, like when it comes time to submit things, that might be an issue. And I think the person who was asking this, Jessica, is maybe more concerned, like if you have a fall semester class and you're using TinyPic, but students may not actually do the submission until spring semester, then they may have to take their images. Right?
They may have to reload the pictures or something, or touch them somewhere during the year.
Yeah. And there were two questions right now about using Google Drive as a server. And you had mentioned that, but maybe you could go over why we can't use Google Drive as a server again.
So when I first built this lesson, I did use Google Drive as a server, and it worked beautifully until a few weeks passed and Ralph Morelli tried to access it and nothing was showing up. And Ralph eventually did some work and chased down the fact that Google tends to, if you try to use Google Drive as an image server, they tend to scramble the URLs on you after a few days. And we suspect they do this purposely to keep you from using their Drive facilities as a free image server, although we're not sure. There may be some other reason that they do it. But basically it became a problem. And so now you'd have a problem where it would only work for a day or two, and then all of a sudden the URLs that you referenced in the Firebase database are no longer valid. That's the issue. Okay, so the URLs change over time, which means that your code breaks then. Right. Okay. And then there was a question from Victor who was asking, is there a lesson using TinyWebDB, or is there only a TinyDB lesson? And I realize this may be confusing for those of you who are just starting to use the Mobile CSP curriculum this year. We don't have any lessons that use TinyWebDB anymore. We used to have lessons that use TinyWebDB. This summer, we converted them to use Firebase instead. So we no longer use TinyWebDB in Mobile CSP. It's still there in App Inventor as a component that you are welcome to use, but it's not a part of our curriculum any longer. And I just want to stress that setting up those databases is not a trivial matter. The TinyWebDB one. Right. There is and correct my terminology if I'm wrong, but there's like a default one that you can use as you were playing around. But if you want anything more permanent, you have to set up your own TinyWebDB, and that is not, like you said, an easy process. Right. Okay. All right. Wonderful. Well, I'll just remind people that if you have questions or more questions as we go along, please keep feeling free to post those comments and thoughts in the
the chat area of the watch page. I'm going to go back to the presentation just briefly here and go through a little bit of the next couple of lessons in Unit 6. So oops, let me share my screen. There we go. So the other lessons that are in the unit, one of them, as I mentioned, is on big data, which is kind of an overview of issues around data. And then there are two later on that are related to fusion tables. One is an introduction one where students follow some tutorials on how to create and import data into a fusion table and create some visualizations from that data. And then the second one is a data project that has a write-up similar to, but not as extensive as the Explore and the Create write-ups. When I teach this at the undergraduate college level, I make the data projects one of the assignments that students have to turn in. Basically, it's an every other week format, but it's like their assignment for the unit is they turn that one in. So I'll just give you a quick demo with Fusion Tables. This follows the tutorial that is linked in there, and I'll walk through how to import data into it, some notes about the types of data that you'll see in this particular data set, and some notes on creating charts. So I am going to switch to my Google Drive window here. And I have already added Fusion Tables as an app as part of Google Drive, but that will be the first thing that you'll need to do. And if you're in a school that uses Google Apps for Education, you'll need to speak to your Google Apps for Education administrator, usually someone in your IT department, to make sure that they've enabled Fusion Tables so that you can use them with, and the students can use them with their accounts if they're using, school accounts to access the course and for Google Drive and that sort of thing. When I first did it at Scholastica, we did not have that enabled. And so because I hadn't checked it ahead of time, I had just been using my personal email. It stopped us in our tracks for that lesson. So you do want to check that ahead of time. Once you've got it added as an app for Google Drive, then you can just click on Google Fusion Tables here, and it'll prompt you to create a new one. And it has a little wizard to walk you through the steps for creating the Fusion table. I've already downloaded the file that I'm going to import here. So this is, it maybe is kind of small to read here, but it's what's called a CSV, or comma separated values file. And basically it just has rows of information, and each piece of data in that row is separated by a comma or some other, like a tab or that sort of thing. We'll just wait for that to import. And you can see here it says separator character. I'll leave that on comma and just click next. And it's going to ask me about the headings for my data. The first row happens to have the headings or the column names. And so I will just click next here. And then I can give it a name and attribute data to. If your students are doing this, they should put the URL for where they found the data in there so that they have that information for later reference. And then you can click finish. So Fusion Tables is similar to, but not quite the same as a Google spreadsheet. So just maybe to clarify the differences, Google spreadsheets or a Microsoft Excel spreadsheet is going to allow you to do things like enter formulas, as well as create some visualizations such as charts and graphs. The Fusion Tables is not going to allow you to do that additional piece. It will allow you to really focus on the visualization aspect of it and do some filtering and that sort of thing. So in this Fusion table here, this is related to sightings of, I think they're butterflies and caterpillars that go together here down in Costa Rica. So, whoops. I am just going to pause for a moment because people have said that they can't see my screen. I really apologize. Let me switch back here. Oops. Sorry about that. I left it on Chandon there. Oops. So probably the best thing is for me just to show you how to create it one more time. I apologize that you're going to have to listen to it one more time, but here I am in Google Drive. I'm going to click on the More button, and here's Google Fusion Tables. Again, like I said, there's that Connect More Apps if you need to use it. So I'll click that, and then here is the beginning of the wizard. I'll click Choose File and pick my data, and I'll walk through the import process just so you can see what the screen looks like here. And this is where it's asking you if the information in the first row is going to be the column names for your data. And then here's where you get to put in some of that metadata about your file, including where students might have found the data, where they downloaded it from off the web. All right, so hopefully everybody is now able to see the information or the Fusion table here. That Fusion table, like I mentioned, is not quite like a spreadsheet, similar to, but not quite the same in that you're not entering formulas, and it's more focused on the visualization side of things. One of the things that we'd really like you to emphasize or talk through with students is to think about the types of data that they're seeing here. So in this example, and this is one that comes with the Google Fusion Tables tutorial, there's species information, which is text data. There's voucher information, which I think is related to some of the tagging related to the sightings of the butterflies. And then you saw there's two columns, URL adult and URL CP lateral, and I believe that's referring to the caterpillar. So it's URLs for the images that go with it. Then there's a sex column. This one is interesting to think about. It's text data, but it's very structured because there are only 3 possible values that are listed: female, male, and then blank. So it's very, very structured in terms of the data and limited number of values that you'll see there. Then we have some more text data related to the species and the family for the host plant. We have some date time information with the year, and then with the date eclosion listed in the next column. So while it looks like numeric information, it's a little bit different because it represents a date or a time for the citing of that information. The next one, elevation, that is definitely a numeric type of value, as is wingspan. I can expand this column so you can see that a little better. And then primary ecosystem is the next column. That's similar to the sex, where there's a limited set of values. We have dry forest, rainforest, some blank ones, and then I think cloud forest was the last one. And then finally, we have that geocoded data, latitude and longitude. The reason why I like to walk through that with students is that when they go to create their visualizations, they need to be thinking about what kinds of functions and types of charts they can use with that data. So for example, they cannot calculate the average for text columns. So they can't calculate the average sex or the average species, but they can calculate the average wingspan and the average elevation. So making those connections for students helps them hopefully when they go to create the visualizations. That geocoded data, latitude and longitude, Google Fusion Tables creates a map for you based on that information. When I was working with a student today, they couldn't see the points on the map because they had actually zoomed in on the United States. So you do have to make sure you're looking at the right area in order to see the data. And then when you click on each of these points on the map, let me zoom in a little further to click on it. There we go. You'll get a little card or a little pop-up about the data that is contained from that point. The tutorial walks students through on how to edit it so that they can customize their maps and show different information in these little pop-up cards. Okay. I'm just going to click on this red plus button here. This is what will allow you to create additional charts or different maps or that kind of thing. If I click on Add Chart, I'll just walk you through one example that shows you how to create a visualization related to gender here. So over on the far left-hand side, you see all the different kinds of chart types over here. And they will, Google Fusion Tables will try to guess the kind of chart that you want or the data that you want in the chart. I'm actually going to pick the bar chart here. And then for category, I'm just going to switch this to sex as my category. One of the things that you'll notice down here is you'll see that there's a whole bunch of columns for female and male. Often you will need to click the checkbox next to summarize data so that it combines that data together. So initially, it will create the data from the first 10 rows. See how it says maximum categories 10 here? So it's only showing the first 10 rows. If I click summarize data, what it's going to do is apply the count function to that column or to that category, and it's going to count up how many rows have a blank for a value, how many rows have male for a value, and how many rows have female for a value. So this is a bar chart that would just show me a count of that different set of information. If I had students working on a hypothesis like males have a larger wingspan than females, one of the things you could ask them to do then is to calculate the average wingspan, and they would just come over to that category area again, and under wingspan you'll see, because that is a numeric piece of information, they can apply one of these summary functions, min, max, average, or sum, to that data. So I've checked the average box next to that. And now you can see my average, or the red column here, shows the wingspan. You don't want it to show the count of the number of rows related to each of the genders. You can uncheck that at this point. So now it's just showing me average wingspan, male, the blanks, and then the females. You can see that my hypothesis was wrong. Females tend to have a larger wingspan on average than males. So that's kind of an overview of using some of the categories and summary data information. The other thing that I would make sure you point out with students is that under this change appearance button, they should be thinking about having a title and adding X and Y axes labels to their graphs and their visualizations. So I can add gender here like that. I can go back and add a title, average wingspan by gender. You really want to help them and make sure that they are creating good visualizations that have these labels on them so that they're easy for other people to read. Once you've got this created, you would click on the Done button, and then it would show up as a regular chart. You can always go back and edit it by coming up to the drop down next to the chart name and clicking Change Chart. So that's just a quick overview of using Fusion tables. Like I said, the last couple of lessons, the last 2 lessons in the unit are about walking through this tutorial on using Fusion tables. And then there's a data visualization project where they collaborate and work in pairs to select a data set and then develop some questions and corresponding hypotheses about the data. There is a linked document, Google Doc here, that has some suggestions for example data sets that they could use. That's just a starting point though. Feel free to push them to think more about data that they're interested in and go out and find it on the web. Many times when you go to these data sites, they're going to have options for students to download those CSV files or even a spreadsheet file and then be able to import it into the Fusion table. Again, they're going to want to think about the kind of data that's there and the kind of analysis that they can do. Can they do counts on text data? Can they do average, minimum, maximum, summary kind of information on numeric data? Can they show trends over time with date time data, that kind of thing? I'll just point out towards the bottom, there are some ones like this tuvalabs.com where you can create accounts for your class, and it's designed specifically for K-12 teachers. Many of them, however, are open data sets that are maintained by the government or by international agencies such as the World Bank. All right, so that is kind of a quick overview of those 2 lessons, the Fusion tables and then the data project that comes after it. Let me stop sharing my screen and we'll check in and see if there's any questions that people have about either of those. So it looks like there was a question about finding appropriate data sets. Hopefully, Marcia, that answered it. When you go to the project page, you can go to that link and look for data sets that people can download there. Let's see. And then Victor was asking about 5 different data types. I just kind of gave a broad overview. Certainly text is one type of data. There's different kinds of numeric data, including whether or not something is a currency value, whether it's a straight up like numeric value, whether it's percentage data, that kind of thing. You just want students to be thinking about it and the kind of analysis that makes sense. They probably, I would hope they've been doing some of that kind of analysis in their math classes, and so to make those connections there. Are there any other questions about Fusion tables or the data sets? I'll leave this up for a little bit longer. Chandon, do you have any thoughts or experiences that you want to share as a teacher about using Fusion tables in your classroom?
So I think that the lessons that you've shown are tremendous, and I think they will get the students' feet wet on how to use the Fusion tables. For my advanced students, I actually let them build their own Fusion table from scratch and have an App Inventor 2 app read and write to the Fusion table. And there are some particular challenges associated with security. Setting up the security between a Google Fusion table and an App Inventor 2 is actually fairly challenging. It's a worthwhile exercise for advanced students because once you can have a mobile app talk to a Fusion table, you can build some really, really great applications. There's an example given, for example, about the guy who was trying to calculate in real time the inflation rate in Haiti, and he had these people shopping in the marketplace, entering information on the app about the price of rice and beans and things like that, and this information automatically showed up on a Google Fusion table and could be analyzed in real time. So there's some very powerful things you can do with this technology. There is a video on YouTube that's listed in the sources that explains how to set up the security between a Fusion table and an App Inventor 2 app. That can be a little bit intimidating, but once you get that done, then the actual code to read and write the Fusion table from the App Inventor 2 is actually fairly trivial. Just wanted to mention that.
Sure. And in previous years, we had an optional tutorial in Unit 6. It was called like Hello World Fusion Table app that gave a demo of how to do that. We've moved that to the unit where it says beyond the AP exam. So after the sample AP exam questions and preparing for it, there's a unit, I want to say it's Unit 9. Yes, Unit 9 that you can go to that has a couple extra App Inventor tutorials, and that is where the Hello World Fusion Table app is. So if you have students who are advanced or maybe could use that kind of functionality where you're wanting to, collect data from an app and be able to store it there, then they could look at that tutorial to figure out how to connect to Fusion tables from App Inventor. Let me go back to the comments page here. So I'm seeing a couple questions come through and just a couple of comments. So John was sharing that the setup, like you mentioned, Shannon, can be challenging, but the video on YouTube did help last year. This is the kind of thing that we would encourage you to suggest to students either after the AP exam or only for students more advanced, because we'd recommend that they get more practice with Firebase, the Firebase database, and being able to store and retrieve information from Firebase before they work on Fusion tables. So we're going to keep it in Unit 9, but please know it's there, and you can feel free to refer students to it at any point. Great. So just as a reminder, we have a couple more webinars coming up. So we're going to leave December free for folks so that there is no webinar during December. In January, early January, January 10th, we're going to have a webinar about technical writing and helping students do a better job of preparing for that Explore performance task. In February, on February 14th, we're going to go over Thunkable, which is an alternative to App Inventor that is looking at ways that they can help deploy an app not just on Android devices, but on iPhones and iOS devices as well. and is really trying to do a nice job in terms of thinking about making their interface and very user-friendly. In March, we're going to do another review of the performance test and getting ready and how to help your students get ready for the exam. So just a reminder that those are coming up in spring semester. This is the last webinar for 2016, although I'm sure many of you have meetings set up with your mentors and your masters, and you're always welcome to pose questions in the discussion forum and that sort of thing. So, Shannon, I just want to say thank you again for joining me this evening and helping me present information on the data unit in Mobile CSP. I appreciate your expertise from the classroom.
Thank you very much for inviting me.
All right, thank you everyone. Have a good evening. And again, just feel free to post questions in the forum and we'll get back to you there.